Choosing the right thermostat and condenser wiring gauge matters more than most homeowners realize for safety, signal integrity, and code compliance. Here's why 18-gauge wire is the recommended standard for low-voltage HVAC controls. 18-gauge wire offers the perfect balance of current capacity and flexibility for thermostat and condenser control circuits. So start by confirming your thermostat requires low-voltage control and that the run length between the thermostat, air handler, and condenser is within code limits. Measure the longest conductor run and keep it under the manufacturer's specified maximum for voltage drop. Use 3-conductor 18-gauge for basic condenser control and 6-conductor 18-gauge for multifunction thermostats that handle heat, cool, fan, and common power. Label each conductor at both ends with durable tags or heat shrink labels so future techs can trace circuits quickly. Pull stranded copper 18-gauge, not solid, where the cable will see movement or be routed through flex conduits to avoid breakage. If using thermostat wire in walls, choose cable rated for in-wall installation and keep it separated from high-voltage wiring by at least the distance required in your local code. When terminating, strip only the minimum insulation. Tin the ends only when the terminal design allows it, and tighten screws to the torque the equipment manufacturer specifies to prevent high-resistance joints that cause intermittent operation. For long runs, calculate voltage drop. For control signals, a small drop can still cause read errors. If you exceed allowable drop, upsize to 16-gauge or run a dedicated 24-volt transformer closer to the thermostat location. Grounding and shielding are unnecessary for standard low-voltage thermostat circuits unless you have significant electromagnetic interference. If you do, use twisted pair or shielded cable and bond the shield at one end only. Always verify compatibility with the condenser and thermostat manuals. Some heat pump or variable speed systems require additional conductors or a common wire, and some modern smart thermostats require a dedicated common conductor to power their electronics. Finally, follow local building and electrical codes, pull permits when required, and test every circuit with a multimeter and system-level test routine before closing walls. One of the biggest thermostat wiring mistakes is using undersized wire or aluminum conductors, which causes voltage drop and poor control response. Fix this by running copper 18-gauge or larger as specified and redoing any suspect runs. One of the next common errors is skipping the common 24-volt conductor for smart thermostats, resulting in frequent dead batteries or reboot loops. Fix by running a 6-conductor 18-gauge cable or installing a common adapter or an additional transformer. One of the third frequent issues is improper labeling and loose terminations that lead to intermittent compressor short cycling. Fix by labeling each conductor clearly, torquing terminals to spec, and performing a full system startup sequence to confirm correct staging. BigHomeProjects.com lists vetted local HVAC contractors and provides clear subcategory searches for thermostat installation and condenser wiring services to help homeowners connect with qualified pros that follow code and best practices. The directory also helps contractors get work by showcasing verified reviews and service coverage areas, so tradespeople win jobs from homeowners seeking compliant, high-quality thermostat and condenser wiring.